Hey guys, thanks for the throw. We're here with James Smith, who's the CEO for Bugsnag. They make some tools that help you monitor your code for errors, and they have a new report. James, welcome to the show.
Thanks for having me, Mike.
So I looked at the report, and it says, as I understand it anyway, that the median stability for mobile apps is 99.63%, and the median stability for web apps is 99.39%. And I'm thinking maybe developers should be doing a little happy dance, but maybe not so fast. So explain this to me.
Yeah, well, I think if you're used to measuring these numbers, maybe you have an idea of what they mean, but most people aren't measuring the software stability in a score like this. I think that if you're familiar with the availability metrics, like 5 nines of availability or uptime that site reliability engineers and DevOps teams almost certainly are looking at or striving for, you'll notice there's a lot fewer nines on those numbers than you get with the availability or uptime. And that's really where the problem comes in. I think that it's difficult to understand numbers with a lot of nines in sometimes. And in reality, you want that to be as close to 5+ nines as possible to reduce the number of poor experiences for your customers. So one way of thinking about this is, 99.3 means that you're seeing more 7 out of 1,000 customers seeing a crash. You're spending money on developing software, and 7 out of 1,000 customers are seeing an unstable experience. Maybe they're buying that hot ticket expensive item on your e-commerce website, or maybe they are your key customer that's about to click renew on your SaaS product, or maybe they're buying an in-game transaction in game, and that means that they're going to churn out and not buy that next time round. It's 7 out of 1,000 customers. If they came into your target store and got kicked out straight away, you'd call that a failing experience.
So Murphy's Law would dictate that one of those 7 is going to be my most important customer of the day or the week or whatever it's going to be.
Right, exactly. And even more painful than that is that, consumers tend to be quite vocal and quite loud. And again, it's a silly analogy to make, but if you walked into Walmart and you got kicked out because they're like, no, you can't come into our store, you're going to go and post about that on social media, and you're going to go and tell your friends, and that's going to do a lot of brand damage as well. You're not going to want to come back into that Walmart ever again. So yeah, not just individual transactions at risk, or most paying valuable customers, but also, hey, you don't want to turn people away at the door. This is going to hurt your brand reputation.
You guys also looked at Apple and Android and what the platforms were. So what did you guys discover about the reliability of apps on those 2 platforms? Is there a big difference?
There's a meaningful difference, a statistically significant difference. And it's kind of not surprising here. The Android applications have to run in a lot more varied environments. And so unsurprisingly, our report found that Android applications are slightly less stable than iOS applications. But again, this wasn't something that necessarily surprised us. There are stability issues that are caused by code changes. Hey, we did this change in our code, and that caused a bug to happen to everyone who's running the application. And then there's stability issues that may not have been shaken out because of differences in environment that you're running the software in. So, I'm not sure how many versions of the iPhone are out there, but there's probably 100 different versions of the iPhone since the launch of the iPhone, something like that. But on the Android side of things, there are tens of thousands of Android devices out there. And almost certainly you're not going to even scratch the surface on testing your software on all of those devices. Also, that fragmented device differences are compounded by the fact that Android phone sellers, manufacturers, typically change the operating system themselves. You'll see this if you've ever looked at a Samsung phone versus an LG phone. They look very different. Sure, it's core Android, but those manufacturers have futzed around with the software that makes up the operating system. And so your software is not running in a clean room environment on all of these devices. Now, that's a general problem on client-side software development, but it's certainly compounded on Android, where there are tens of thousands of different types of device out there compared to the relatively sanitized world of iOS software development.
The other thing that caught my eye in this report is that React frameworks were a little less stable than other frameworks. Is that a maturity issue, or is that the nature of the way the React applications are built, or what went into that?
Yeah, if you see in the report, there's a real bad offender was Backbone JS in particular, and I think that was mainly because this is an old framework, an old JavaScript framework. React, compared to some of the other JavaScript frameworks that we looked at, it wasn't too poorly performing. It wasn't a bad offender, but I think that a lot of the time it depends on features of the framework. Now, I'll talk about Backbone again briefly. Backbone was this way of building a JavaScript application really from scaffold, right? It gives you the raw parts to build a JavaScript application. It didn't really have an opinion about things. And so, again, there was no surprise that we saw that Backbone JS apps were a lot less stable than some of the more modern frameworks. The differences between the Reacts and the Embers and the Angulars of the world was a lot less stark, but there were differences. And in my mind, that's, I think, partly due to the fact that some of these platforms have opinions about error handling and some don't. There are built-in, baked-in error handling capabilities of some of these JavaScript frameworks. React has some error handling capabilities, but not all developers have adopted these. There's something called an error boundary in React that, it's been out for a couple of years now, but not every React developer has adopted this concept. And the idea there is, when you're writing user interface, front-end application, errors can bubble out from component context. So you probably want to know if an error happened in the button versus just on the whole page. And so if you're using features of the framework like a React error boundary, you're more likely to see more errors bubble up. Otherwise, you're sticking your fingers in your ears and not hearing about them potentially.
Well, that works for some people. However, one of the things also in the report that stood out to me a little bit was size apparently matters in terms of the engineering teams that are at work here and the stability. So what's the correlation there?
Yeah, we saw, again, when we saw the shape of the curve, we initially were like, uh-oh, that's weird. And then we're like, no, that's exactly what we expected. If you look at the report, we segmented by number of engineers in the company, and that's good proxy for how many people are working on the code base. And what we typically see is if you are a really, really, really small team, 1 to 10, you're going to have the worst experience. You're going to have the highest crash rate. One of the things is that makes a lot of sense when you think about it is probably if you're a small team, you're probably a young company. And you tend to want to take more risks earlier in the company. You don't have so many established practices around how stable should your software be. What are our goals? What are our targets? And also, it's a factor of your go-to-market approach. It might be that you're saying, look, let's ship software as quick as possible, because we don't know if anyone's going to pay for this yet. If you're a startup, it might be a wild and wonderful idea that you don't know if anyone's going to use yet. So it's okay to have some acceptable risk earlier on in the business. So when you're a smaller company, typically it means you're a younger company and you see more risks being taken. So again, no surprises there. And this kind of curve goes up and you can see as the company starts to get bigger, stability score improves. One of the surprising things that we saw, and again, it was obvious in hindsight after we looked at this data, once you get to very large companies, 1,000 plus software engineers, your stability starts to drop again. You don't start to have that improvement anymore. And again, it's not surprising. This is something we've seen with the customers that we work with. When you have hundreds or thousands of software engineers working in code bases, it's very, very difficult to maintain standards of quality. And in addition to that, if you have that larger team, almost certainly you're working on a mature product and an older code base. And as you know, technical debt accrues over time and it sneaks up on you. And so I think it makes a lot of sense to me that we would see small teams take a lot of risk, see higher crash rate and lower stability. It improves over time as you build rigor and process into your teams. But it falls apart once you get an older code base or a much larger engineering team. So that's exactly the results we saw in the report.
We hear a lot of people talking about digital business transformation these days. Almost invariably, that involves a web app or a mobile app, and they're building out more of these apps than ever. Do you think that for maybe they're in danger of having all this stuff come back and bite them in the butt a little bit because the stability issues are going to be out there? The more apps they build, and they may not have the right number of engineers, they may have too many projects going at the same time. Do people need to think that through, or is it just kind of the Wild West and we're hoping for the best?
Well, it really depends on the type of company you're building, but you're right that there's tech forward companies, there's technology companies that we understand and know that exist only on the web or mobile. Like the Airbnbs of the world exist purely on the internet. For the companies that are, especially within the last year, have been forced online, who are traditional businesses that have to move their storefront online, it's difficult because if you aren't a technical expert, you don't know how to build these processes. Sure, you can work with a consultancy, you can speak with the analysts to find best practices, but you're effectively having to build your technical expertise from scratch. One of the issues there is that the people on the commercial side of the business, the decision makers, don't necessarily understand what stability or performance or availability mean. And they might be shown a beta version of the application that works on their brand new iPhone. The CEO gets a copy and they're like, great, the Burger King application looks great. I can order a burger on here. But most of the people out there aren't using that same device, or maybe they're going into a lot more depth and finding more bugs that the CEO didn't find. So the CEO, maybe when they click the launch button and they do that in huge marketing spend to launch the new version of your application, hey, you can now buy on our app. They don't know what the risks are when they're clicking go and taking that out to their customer base because they are not experts in technology. So I think that I don't think it's necessarily a Wild West intentionally. I think that there's just a lot of people who are having to go through that learning curve in a really accelerated period of time. And there's a lot of demand for bringing in seasoned CIOs and CTOs at the moment. And so can you find that person in time to do your digital transformation? So yeah, I think that everyone's going through that change right now as a matter of a forcing function over the last year. And that's not slowing down and that's not going away. And I think that the nuances of talking to your customers through a different storefront, I think are going to have to be learned by all of these organizations, especially on e-commerce. E-commerce is going to be, I made the analogy at the beginning of the conversation about there would be an uproar from the CEO if people were turned away at the door from your storefront from Target or Walmart or whatever. And that's effectively what's happening when you have software issues that aren't addressed.
Do you think more organizations will adopt best DevOps practices to manage all that? Because when I look at it, it looks to me at least that things are getting more complex, not less. There's more APIs. People are throwing around microservices now. There's front ends and back ends. How do I keep all this stuff synchronized?
I think that there's the best practices in terms of how you build your software, and then the best practices of how you run and monitor your software. And I think the latter is far behind the former. There's been for people who are savvy, companies that are savvy, they are adopting DevOps best practices and they've adopted CI/CD and they've moved from waterfall to agile and all of the stuff that we've been talking about for years. A lot of that has happened already, and that's been trained and ingrained into CIO, CTOs' minds. But I think that the feedback loop is missing. So the feedback loop is almost the purest way of looking at this. What goals are we setting for our digital experience? Do we want to have X people using our product? Out of those people, what percentage do we want to have a good experience? How are we going to prove that they did or didn't have a good experience? So I think that one of the risks of the transitions over the past 5-10 years is that people have been sold the dream. The dream has introduced a lot of complexity, as you say, but we haven't set our goals necessarily. Also, goal setting you mentioned this earlier, the digital storefront is the client side. Yes, you've got all these microservices and APIs and serverless and stuff happening behind the scenes. But arguably, DevOps and SRE teams and sysadmins have had quite a long time to build best practices and goals there. Web technologies on the back end have been around for quite a long time. Yes, they've evolved. Yes, they're very different. But most teams have a concept of an error rate. Even looking at what percentage of your customers are seeing a 500 error. That's a pretty baked in best practice by now. What I think a lot of people aren't doing is thinking about that from the customer's perspective. They're thinking about it from the code perspective or the infrastructure perspective, but not from the customer's perspective, which is where the customer is touching the code, which is the client side. So I think that adopting these things, best practices, has been great. I think it's more complex than people expected. And I think that people haven't done it necessarily in a way where they understand the repercussions of that. So it's the complexity does lead to issues, but customer experience, I think, is the one where we're not thinking about the most.
Do you worry at all that we're experimenting on customers in real time and throwing apps out there and developers are like, well, if they don't like it, we'll just fix it in the next run? And I'm not sure that's any way to run a railroad. So what do you think?
Yeah, it's definitely industry dependent. I started my career working in financial technology, and before that I worked in embedded software, writing software for medical pumps. Now, writing software for medical pumps, it's safety critical. There are no bugs. Or if you're writing software for the space shuttle or whatever it is, there's a risk tolerance slider that you have to set in your business. I do think that experimentation, there's this phrase that I hate called testing in production, and it's a hot phrase at the moment. I just don't think it's a very respectful way of talking about this. I think if you're intentional about the way you're rolling out software to customers, I think it is an asset to be able to take a little bit of risk on board. So what I mean by that is, like, again, if you're a bank or you're the space shuttle or if you're a medical pump, you probably want to have a very tight risk tolerance. You want to make sure that you're not sending poor software to your customers because it could cost lives or millions of dollars or whatever. But if you're a startup and you're trying to figure out if people want to use this product, it is a competitive benefit for you to be able to ship software and features faster because you don't have an established business model necessarily yet. You might beat your competition to market. I think that a good way of doing that, and again, if you're doing this intentionally, is to do intentional phased rollouts. So people have been running beta programs for a long time. What I've really liked recently is self opt-in for beta programs. And on mobile, this is very prevalent. If you are an Android user, for example, you can go to the Google Play Store. Certain companies will say opt into the beta program. You can click one button. You don't have to fill in a form or anything. So you're saying, hi, company, I have a higher risk tolerance and I want the features now. And so you are allowing the customer to opt into that riskier beta experience. That's a really good way of doing it. You're not forcing poor quality software on your customers. Another way of doing it is to do fast automated rollouts and rollbacks. A lot of companies are using experiment or feature flags now at scale. If you're using built your own homegrown feature flagging system, or if you're using something like Launch Darkly or Split, these are off-the-shelf feature flagging systems. What you can do is you can turn on certain features or parts of your code base to a subset of your customer base. Again, if you do that, you have to have a feedback loop. Are those customers that you're giving this new feature to having a worse experience than the control set, the rest of the customer base? And if you do that and measure it correctly, you can see if there are defects and then automatically turn off those feature flags because they're controlled by a kill switch on a remote server. It's not like you have to then force the customer to upgrade to version 2 of your application and give them a poor experience. So again, be intentional about it and it's okay, and know where you are on that risk profile slider. I think it can generate huge improvements in competitiveness and getting features to your customers faster.
All right. It's just like going to Vegas, only risk what you can afford to lose, right?
Exactly.
All right. Hey, James, thanks for being on the show.
Thanks for having me.
All right. Back to you guys in the studio.